Okay, so Big Ideas is the companion website to our new math series, and it's a great place to go if you're struggling with any of the concepts that we're talking about in mathematics. Because as you work through problems on that Big Ideas assignment, if you run into something that you're not getting quite right, then they give you a little instructional video right then and there instead of you getting to the point of frustration. So remember, you can go to Big Ideas by just typing in Big Ideas in any browser, any internet browser, okay? You type in your username and password, and then you click log in. Now your username and password, if it doesn't work, send me an email, and I can always help you get through that, even if I have to do something like log in as you or do some other thing, okay? So try to make sure if you don't remember your username and password, you're going to look on the back of that page that was due for today and see that username and password information. Okay, so when you click into your Big Ideas Math, yours is going to look different than mine. As a matter of fact, I don't even know if I want to do that one because you guys will see my side of the Big Ideas, which isn't a whole bunch different, I guess. Okay. I am going to go ahead and switch to my student account, my pretend student account. Okay, so when I do that, I'll go here. And your guys' username looks like this. It's your first initial, last name, and then 3 digits, and then your password is your first initial, last initial, and then your student ID number, okay? So when you get to your classroom in Big Ideas, it's going to look like this. Here are spots where you can do extra practice, and here is your assignment. By the way, it is due tomorrow, so any extra credit points have to be earned today sometime. I believe at midnight, then it's not there anymore. I'll collect everything and it'll automatically grade most of it. And I'll be adding those bonus points on to your overall grades. Okay, remember you can just click there and answer the questions as they come up. Okay, I've already showed you this. There's like 30 some questions. Do I have to do all of them to get the extra credit, Mrs. Franzen? I would like you to at least attempt them all. Okay. The other way to get to this, Big Ideas, is if you go to your, say I'm in my Google account, in my classes, right? If I go to Mrs. Franzen's live class and I go to classwork, the other way to get there is by classwork, and it's up here, multiplying fractions. This red pin is going to identify those assignments that are linked to the Big Ideas website. So those are your digital assignments. And in this case, it's not technically an assignment, but it's extra credit, and I encourage everybody to give it a try. Okay, even if you don't think you need extra credit because you've got an A in math right now, I still want you to give it a try, okay? So then you'll log in through that and it'll get you to the same place. See, I'm still in there as my alter ego. Okay, so back to the meeting here. We're going to go ahead today and we're going to work through a few of the problems, okay? So all you really need on your desk is just a pencil for now. And actually, I think what we'll do is have everybody have their worksheet as well. And on that worksheet, then you're going to fold it like we would an assignment paper. Okay, on the back of the worksheet, we're going to have 17, 18, 19, 20, 21, and 22 worked out in class as examples, and you're copying what I do, and as I'm talking about the problems, you'll listen. Okay, so go ahead and hand out your papers, everybody. So go ahead and start folding your paper the way I like your assignment papers.
You want to fold it on the top part?
No, the top part doesn't need to be folded down because this is not the average sheet of paper. It's not a lined piece of paper. Okay. there's any extra, put them up here, please. You have them, Brett? Have you folded it? And remember, you fold them in half the hot dog style once, and then fold it hamburger style down twice. So the first rectangle that you get, you're going to put the number 17 in there to identify that's the question number you're working on, right? Sorry. Okay. So if you notice on the front of the page, it says 4 3/8. Okay, remember how when we watched the video on Thursday, Con from Khan Academy said we have to take those whole numbers and we have to change them into the smaller parts that the fraction tells us to. So since we have 4 3/8, we need to break that, we need to chop that 4 up into 8. And how we do that is we multiply the 8 times the 4. And then we add the numerator, right? So here's what we do. Between the 8 and the 4, we multiply. 8 times 4, everybody?
32.
Plus 3 more? Yep, we had to add the extra 3/8 in there. So we have 35 eighths. Okay? That is simply changing a mixed number into an improper fraction. Now we have to change the 2 into sevenths.
Ms. Franzen, can you wait just a second while they get their paper done and their question written real quick?
Yep.
Thanks.
Yep, so on the back of your page, you're going to write number 17. You're going to copy the problem down into that one rectangle, and then follow along with me as I write. I don't like this skinny pen. I'm actually going to undo. I don't know why, but I like the fatter marker pen on here. I really like the blue color. I'm going to get rid of this screen. Bye, guys. All right. I'm kind of going to be walking around today a little tiny bit, so if I get too quiet, if I get too far from my microphone, let me know.
Okay, hey, thanks, we got it.
Okay, so again, I have to change that whole number 4 into parts, into eighths. So what I do is multiply the 8 times the 4, and I get 32, and I have to add the numerator of that fraction. I have to make an addition problem there. So that is 35 eighths times, now I have to change the 2, the whole number 2, into parts, and the parts need to be sevenths. So I multiply 2 times 7, and I get 14, and I add the 2 in the numerator to it. So I get 16 sevenths, okay? Now, here's where we could simplify before we multiply, right? Okay, because we know all about prime factors, don't we? We know a 35 is really 5 times 7. That's the prime factorization of 35. And we know the prime factorization of 16 is 4 2's. Multiply 4 2's together, always you're going to get a 16. The prime factorization for an 8 is 3 2's, 2 times 2 times 2. And the prime factorization for a 7 is just a 7. Okay? And we also know whatever's on top, we can cancel out on the bottom if there's the same amount of them. So let's look at that. There's at least 1 2, there's at least another 2, a third 2, a 7, and then we're done. We have nothing left on the bottom and only a 5 and a 2 on top. So our answer would be whatever 5 times 2 is, That is 10 over 1 because there's nothing left on the bottom. So is 10 over the 1 the same as 10 once or 10 wholes? Yes. So our answer can just be the number 10. Okay, so that is your answer for number 17. Let's look at number 18 together. Number 18, I just want to rewrite. I'm going to encourage you to write it like this, okay? Put one long line. After you copy the problem down in your workspace, I want you to just put one long line. Sounds like I'm speaking Chinese. One long line. Sorry, I'll stop. No offense to anybody who might be Asian. So you're multiplying 1/8 times 3/5 times 2/3. So in the numerator, we have a 1. So I want you to put a 1 on top. Times 3, that's prime, so I'm going to put that there. And 2 is also prime, so I'm going to put him there. 1 times 3 times 2. Now, the denominator of the first fraction was an 1/8, right? So an 1/8 is 2 times 2 times 2 in its prime factor form, right? 2 times 2 times 2. 5 is prime, and 3 is prime. Okay? So remember, if there's 1 on top and 1 on the bottom, we can cancel those puppies out. I see a 3 on top and a 3 on the bottom. I see 1, 2 on top and 1, 2 on the bottom. Which means I can simply just put a 1 because 1 doesn't have anything left to multiply itself to up here. And then we have to multiply 2 times 2 times 5. Careful. So what's our answer for 18?
128.
Okay, once you get really good at this, you're going to notice that, oh, boom, there's a 3 here and a 3 here. I'm going to cancel that out. And you can almost work it out in the problem. There's an 8 here and a 2 there. 8 and 2 both have a 2 in common for factors, right? So then my answer would be 1 times 1 on top and then 4 times 5 on the bottom, which is still 1/20. Okay, so once you get good at recognizing what factors numbers have in common in their prime factorization, you're going to get better at and quicker at simplifying your fractions. Wait, I don't know if everybody was done. Was everybody in here done? Yes.
Just a question. I don't know. Are you recording today?
Yep. I'm recording on Screencastify. Okay. Next question is 6/7 times 6/7. If we really think about this one, we don't have to bust anything down into its prime numbers because 6s and 7s have nothing in common in their prime factorization. So this one I know is going to be simplified already when I multiply it out. You kind of see my logic there? 6s are built with 2 times 3. 7s are built with 1 times 7. Neither of them have any factors in common. So when we multiply the fraction out, we're not going to have to simplify. Okay? So 6 times 6, everybody? 36. 7 times 7, everybody? And I am confident that those two numbers have 0 factors in common because they're built with two numbers that have 0 factors in common other than the number 1 in their prime factorizations. Okay, questions on that one? Okay, go ahead and finish writing that out and we'll move to the next one. The next one is number 20. you think it's enough time?
Yeah.
Mrs. Franzen, you can't put exponents with fractions. Oh, yes, I can. This just means this. We just did an exponent one. We could have written that first question just now as an exponent. 2s and 5s have no factors in common, no common factors. So I know, again, I'm just going to multiply straight across the top. I get a 2 times a 2, which is a 4, and a 5 times a 5, which is? You guys will have to do the first 16 yourselves, and then the last few are done on the back of your paper. Okay. So of course you're going to need a lined piece of paper later when we're done doing these example problems together that you'll attach to this when you're done. I like the puzzles too. Okay, our next question looks like this. All right, so if you have 3/4 squared, it means 3/4 times 3/4 times 1/3. Okay, do you guys see any factors in common on the top and the bottom? The 3's. So let's cancel those 3's out. There's a 3 up here. 3 divided by 3 gives us 1, so those cancel each other out. The 1 and the 4. It'll just stay the same. Yep. So 3 times 1, everybody? 4 times 4? 3/16. Boy, I hope we're right on all of these. I don't think we've made any mistakes. But honestly, I haven't had all my coffee yet this morning, so I'm hoping you guys are catching anything we might have done wrong. Yes? No, because they're side by side. It has to be diagonal up and from the top to the bottom. Yep, you can't cancel side to side like that. Good question. Never do that. So 3/16 is our answer there. Did everybody have a chance to write that in?
Yeah.
And the mathematical thinking too? Okay. We don't know how to do area yet, Mrs. Franzen. Yes, we do. Area is always length times width of something that's rectangular, right? So if you have a photo of your friends at the local amusement park, and it's a rectangular photo, normally photos are rectangular, it's 5 1/3 inches for a width, and 3 1/4 inches tall. Actually, I said that backwards, but still, you could even switch those around, and due to the commutative property of multiplication, it wouldn't matter. Yes?
So when it since all since two sides of the same line or the same like width, wouldn't that be like your answer times 3?
You're thinking perimeter, I'm thinking area. You're thinking the distance around the outside edge of the frame, and area would be how many square units would cover it, how many square inches would be on top of it, right? So good question. This is an area one. So we're going to do multiply here, add there, right? That's how we change those whole numbers into improper fractions when we're dealing with fractions. Okay, so 5 times 3 is, plus 1 is, so this changes to 16/3, still means the same thing. 4 times 3 is, 12 plus 1 more is, okay. Now I can already see, without doing a bunch of prime factoring, that I've got a number with factors in common. I have this number and this number diagonal from one another. How many sets of 2 are in a 4? 2 of them, right? How many sets of 2 are in a 16? 4 of them. Or in other words, 4 divides by 4 and it gives you 1. 16 divided by 4 is 4. Okay. Now I need to know what is the answer to 13 times 4.
22.
Close. Yes,
52.
I've got a 52. Okay, so 52 over, and a 3 times this 1 that's left is just 3. Okay. Now I've got a really improper fraction, don't I? So to finish this problem off, if you have an improper fraction, we consider them not simplified. So what do? Anytime I see an improper fraction as an answer, yes, you divide it out. Okay, so I'm going to go ahead, make some room on my paper right here, I think. I'm going to divide it out. 52, and 3 is the divisor. It goes on the outside. 3, one set of 3 will go into a 5. 3 times 7 gives me 21, so that's as close as I can get. And now I have a remainder of 1, which means I have 1/3 left over, one of those thirds left over. So my answer here is 17 and 1/3. Right? Beautiful. So your job then and your assignment is to get a lined piece of paper, fold it up into 16ths with 8 on the front, 8 on the back. Show me all your mathematical thinking, staple it together, and that is due by tomorrow. So if you haven't yet turned in the assignment that's due by today, you might want to get that done. And don't forget that you can do extra credit online. I'm going to stay on the Google Meet in case any of the students in any of the other classes want to ask me a question. I'm just going to mute and just leave it running. If you guys want to do the same thing, that's fine with me too.
Are you gonna